Okay, hi, Carl here from Hyrel again, and today I wanted to just take a couple of minutes and show you the evolution of our direct ink writing products. We've been in business for about 15 years now, making 3D printers. We started with just filament, and then very quickly we realized that because of our modular approach, we could easily adapt to syringe heads, inkjet heads, heads that could print clay, Vaseline. And so what I'm going to do is show you today how we've evolved from a very small amount of material to basically a continuous amount of material. So first, let me come over here and you will see one of our first heads is called an SDS, which stands for Syringe Dispense System. And you'll see it's very simple design. We use a linear bearing so that this goes back and forth to put pressure on this. We can program it at any feed rate we want. And there's a single number you change in the settings folder to give us the correct amount of volume per movement to give you exactly what you want. You can't tell if you're printing filament, like an ABS or a PLA, or if you're printing with your favorite Vaseline, grease, or epoxy system. And so you'll see this is a 1 cc, this looks like it's a 10, this looks like it's a 30, and this is a big boy, and he's probably 150 cc's or close to that. Now, one of the problems, or one of the evolutions that happens when you start printing is, at first, you start with something small. You're learning how to make a shape, and as progression goes on, quite often they want to make a bigger shape. And that's why we have larger and larger syringes. But at some point in time, we want to go gigantic so that even 100 cc's is not enough material. So at that point, you look at doing a bulk reservoir. A bulk reservoir is a large, can be stainless steel, can be a 50-gallon drum with a small pump on it. Well, the problem with that is that you're so far from where you're dispensing to where you're printing, pressure variations create difficulty in delivering consistently correct amounts of material. One of the solutions for that has been to incorporate a Viscotech head. Now, Viscotech is a company of excellent engineers based in Germany, to the best of my understanding. And they have what they call a progressive cavity pump. And basically what they did is they took the peristaltic motion, like what your intestines or a farmer uses to milk a cow, and they created a rotational version of that that looks something like this. You'll see that it has nice, funny machining, but this is your rotor, I believe, and this goes inside. This is static, therefore it's your stator. And the two of them go together. This gets locked in place, and as this rotates, it creates a little cavity that goes down and meters the material very, very precisely. Okay, normally this comes with a servo motor and a box to control it, but that's very complicated for us and also expensive for you. So what we've done is we have created a system that allows us to incorporate our own drive system, which uses our standard electronic interface circuit board, a stepping motor with a closed loop, high resolution magnetic encoder on it. So you get servo response, servo precision, without the huge cost associated with it, and no big box is required. It can all run from this single board as we plug it into our printer. So this provides a seamless bulk feed system for you at a much better price point. Again, no disrespect to Viscotech. They are a great company that does great engineering. We have incorporated the pumping portion of their system into our heads. This is a Vipro 3. I believe you can even see it right there on the label. That's their standard part. This is where the material goes in. You put in the fitting of choice. And this is their Eco Pin. I believe this one is a 250, and I believe this one is a 600. And the nice thing about the Eco Pin and the Vipro and this is they all have the same direct interface. You can see that little star inside of there. That's called a Lovejoy coupling. And that allows two prongs to go in, and the softer interface material in there will accommodate for irregularities in alignment and precision. So it basically is like a little union, a flexible union between the pump system and the drive system. Okay, now if you were to buy a Vipro 3 or EcoPin, you would still need to supply it with material. So some people just buy a canister and put a simple Tygon tubing like this over. But some people go like, that's so messy and it's so far and that's not what I want. So we created a head system like this where you can load your cylinder, and this one's pretty easy because you just open the latch here, and now there's your canister. So you can take this in your clean room, you can put this in a centrifuge, you can do whatever you need to do to make sure you've got your liquid. And it's pneumatically driven, as you can see. I'm unscrewing the lid from it. So this actually has a shortened version of your standard cartridge, like Home Depot cartridge you'll find for where you go buy your silicone or epoxy system. So this works great because it helps to keep it clean. And your material comes out the bottom. It just plumbs straight into the input here. And then we have a unique feature in that all of these run off of our electronics, which have a CAN bus. What that means is CAN stands for Control Area Network. Every head has its own unique address. So what we allow it to do is clone. And what cloning says is, I want to print with this head, but clone it to this head. And what that means is anytime I give this a command to print, this opens the valve, precisely synchronized, so the material is there to be flow while you're trying to print. And when we stop printing, it closes the valve and stops the material from being pressurized. So that works together seamlessly, and it solves a lot of programming issues for you. Anyway, this is our solution. If you find it interesting, give Davo a contact and call, and he can give you better training on it. We also have a lot of great YouTube videos out there. So I hope this was helpful, and you guys have a wonderful day.